What is the core concept of chaos mathematics? We find a world with rules easier to understand. The sun rises and sets each day, and the seasons repeat in a fixed order. Mathematics is the study of finding these rules and using them to explain nature. Scientists use mathematical formulas to model natural phenomena and predict what may happen next with computers. But many phenomena in the world are not easy to predict. Wind suddenly changes direction. Waves roll in irregular patterns. Rivers flow in swirling currents. These phenomena seem so complex that they make us wonder whether any rules exist at all. Chaos theory emerged from exactly this question. Many people think of chaos as simple confusion or disorder. But in mathematics, chaos means something different. It may look random, but it follows highly complex rules. Even movements that seem completely accidental can contain hidden order. A famous scene in Jurassic Park explains chaos theory. A scientist shows a drop of water falling on the back of his hand and says it is impossible to predict where it will flow. Why? Tiny differences, small curves in the skin, the direction of a hair, slight changes in the height of blood vessels can alter its path. The smallest difference can lead to a completely different result. Have you ever had a similar experience? Have you ever left home just 5 minutes later than usual on the day of an exam, only to miss the bus because one traffic light changed? Or seen a soccer ball change direction after hitting a small bump in the grass? Small changes can lead to unexpectedly large results. Chaos theory studies exactly this kind of phenomenon. A well-known example of chaos theory explaining a real natural phenomenon is Jupiter's giant red spot. Long ago, astronomers did not know what this spot was. Some thought it was a lava lake, while others believed it was a massive object in the atmosphere. But no one could explain its exact cause. Later, the Voyager spacecraft sent back close-up images, revealing that the spot was a giant vortex. But a new question arose. Why had this vortex not disappeared for hundreds of years? Mathematician Philip Marcus studied Earth's oceans and atmospheric flows to solve this mystery. He discovered that Jupiter's spot was similar to Earth's massive ocean currents. Using complex fluid equations, he created computer simulations. The results showed that Jupiter rotates rapidly every 10 hours, while its atmosphere cannot keep up with that speed. This creates atmospheric drag, which gives rise to the giant vortex. It looked chaotic on the surface, but a clear mathematical order was hidden within. What is the core principle behind chaos? In mathematics, two key ideas are nonlinearity and sensitivity to initial conditions. First, linearity means the result changes in proportion to the input. For example, if the input doubles, the result also doubles. But in nature, such simple relationships are far less common. A tiny change in input can produce a massive change in outcome, or a completely different result. This is called nonlinearity. Powers are a simple example of nonlinearity. If 3 is multiplied by itself twice, the result is 9. If it is multiplied by itself 4 times, the result is 81. The number of multiplications doubled, but the result became 9 times larger. The change is not proportional. Sensitivity to initial conditions is also fascinating. For example, the difference between 0.99 and 1.01 is only 0.02. They feel almost identical. But if those numbers are multiplied repeatedly, the results become completely different. The difference was tiny at first, but repetition creates an enormous gap. This is sensitivity to initial conditions. The phenomenon, often called the butterfly effect, comes from this idea. It is the metaphor that the flap of a butterfly's wings in Brazil could one day help cause a massive storm. Chaos mathematics teaches an important lesson. The world does not move in a simple straight line. Nature is complex, and a small change can greatly alter the future. But that does not mean everything is completely random. Even within complexity, hidden rules and patterns exist. Chaos theory is the mathematics of finding that order. What do you think? Has a very small choice ever greatly changed a day? Can any phenomena in nature seem chaotic at first, but actually move according to hidden rules?